Good morning, all of you. Good morning, all of you. Okay, so my screen is visible to all of you. So I'm going to start this lecture particularly for handwritten recognition on text. So our purpose is to classify text. Before that, we have to we have we have some knowledge about machine learning, some knowledge about what is classification, and then what is recognition. So based on that, we are going to classify some text, and these text are some in the form of numerics data. These numerical data are from 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we will do it by some learning technique. Okay. But before that, we have some knowledge about what is learning. So what is learning? The learning is basically how a person or a machine is learning from some previous data, from some previous experience. So if we talk about the experience, that means, so suppose we are in childhood, we have to classify some fruits amongst like banana, apple, grapes. So how we can identify these uh, apples? So our parents tells us about the apple, the shape of apple is this, color of apple is this, color of banana is this, and shape of banana is this. Based on those properties, based on those experiences, based on those properties, features, we can say features, properties, we can identify. Yes, Chester, do you have any doubt?
No, sir, by mistake, by mistake.
Okay. So based on that, those properties, we can identify the name of the fruits. Similarly, so suppose there are a lot of animals. If someone shows you a picture of an animal, and you have to identify which animal is this. So based on some experiences, past experiences, based on some features in the picture is having, based on the properties picture is having, you can identify which picture is which animal is there in the picture. So basically, what are those properties? We can say those properties are shape, color, and shape, color, etc. These are the features. These are the properties of that particular picture or that particular animal. So based on that, we have to identify animal, we have to classify animals. So suppose there are, about 10 animals. So these 10 animals are dogs, cats, lions, etc. And you have to classify your 10 or 15 pictures among these particular animals. So if someone shows you that this which picture belong to which class, so suppose you got one picture of dog, so you have to identify some features of dog. Previously you have already identified from past experience that shape of the dog is this, color of the dog is this, the face of the dog should be like this. And based on those experience, based on those features, you can identify the picture belongs to dog class. Similarly, you can identify the picture that belong to lion class. So these are the classes. So if we talk about the classes, we can say, so suppose there are 5 classes. One is dog, another is lion, third is cat. And among these 3 classes, there are suppose 5 instances or 5 pictures you have. One is the first is belong to dog class. The second is belong to cat class. Third is belongs to lion class. Similarly, fourth is belongs to dog class, and fifth is belongs to cat class. So now, based on some features, so shape of dog is the first feature is shape, and the second feature is color. And based on this shape feature and color feature, you can identify dog class, cat class, lion class, and of all 5 instances. So based on these features, we have to identify pictures which belongs to which class. Now we will do it by using some machine learning techniques. So for the machine learning technique, we should have, first thing is training data for the experience, for the training of the model, or for the training of the brain. Then we should have some test data. This test data is belong for the evaluation or validation of the trained model. Then we should have some classifier. And the fourth is feature set. So feature set we will identify from the training data. Similarly, feature set we will identify from the test data, and those feature set will be given to the classifier. And what is this classifier? Classifier can be any. There are a lot of classifiers we have: KNN, support vector machine, naive Bayes classifier. These are the statistical based classifiers, and KNN is simplest model for the machine learning classification techniques. So if we talk about classification techniques, this is supervised classification technique. So what is supervised classification techniques? So in case of supervised, if we talk about the ML techniques, we have first is supervised and another is unsupervised. So in supervised, we will have labeled data, and in unsupervised, we don't have any labeled set. So basically, labeled means output of the feature set, properties set, instances will be given in the supervised learning. But in case of unsupervised, we don't have any output based on some properties, based on some features. We can cluster all those instances, and we can identify from which cluster the new test instance is belongs to. So, but in case of supervised, we have some labeled set and we have some output belongs to that particular instance, and we can identify based on some previous experiences, based on some properties, we can identify. Okay, so now So now we have some demo for the handwritten recognition, and by using that particular demo, we will see how handwritten text can be recognized in by using KNN classifier. So before that, we will see what is KNN classifier. So for the KNN classifier, we will have some properties, we will have some parameters, and in KNN classification, there is a KNN. The full form of KNN is K nearest neighbor. And here K means number of particular classes. So based on K, how many nearest values we have. So based on the K, we will identify the instance, the new instance from which class it belongs to. So suppose we have two parameters. The first parameter is this, and the second parameter is this. And now we have some instances, and that if we draw the data points for those instances, so suppose there are two classes, and the first class is this asterisk, and the second class is this particular dot, and our data will belong to either this class or this class. So suppose there are 10 instances, and these 10 instances belongs to or related to this particular graph. If we talk about the first 5 instances, those data points are these, this, and this. Similarly, if we talk about the second class, so suppose the first is this, second is this, third is this, fourth is this, and fifth is this. Now suppose another 11th instance comes to you, and this particular instance, suppose this belongs to this particular thing. Now what we will do, if K value is 3, so we will identify the nearest value of this particular instance till 3 instances. So we will identify which is nearest. So we can see either this or this is nearest. So we will identify 3 instances, which 3 instances are nearby. So if we will draw this, we have to find out the Euclidean distance between this, 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 and this. So for all instances, we have to identify Euclidean distance, and then based on this Euclidean distance, we can calculate which instances are nearby. So suppose there are these 3 instances which are nearby are this. So suppose these 3 instances are nearby, but among those, these 2 belongs to dot class, and this one instance belongs to this asterisk class. So based on the voting, we will identify this new instance belongs to this dot class. So this is the particularly K nearest neighbor. So suppose this is for 3, K value is equals to 3, and suppose if we identify K is 5, so we have to check for 5 nearest values. So suppose if we find out K is equals to 5, then we can identify that these 5 instances are nearby to this particular new instance. Now we can see these two are, there are 2 different instances which belongs to dot class, and there are 3 different instances which belongs to asterisk class. So we can see these 3 asterisk belongs to these three instances are belongs to asterisk class. And now voting mechanism, by using voting mechanism, we can see there are 3 different instances which belongs to asterisk class, and 2 different instances belongs to dot class. Now we have greater value is asterisk. So we can identify this new instance belongs to asterisk class. Similarly, if we identify k is equals to 7, so we have to check 7 different instances which will near which are the nearest to the this particular instance, and based on that we can check the voting mechanism, and after that we will identify the new instance which from which class it belongs to. Now we will see the demo version of the handwritten recognition. So let me share my screen first. Now, so for the demo purpose, we have identified one MNIST handwritten digit recognition, and in the handwritten digit recognition, there are 10 number of classes. So you have to identify the new instance or new test set belongs to which particular digit, either 0, 1, 2, 3, 4, 5, 6, 7, 8 or 9. So for that purpose, we should have some libraries, and these library belongs to Python programming language. So for the first, we have NumPy, that is for numeric purpose. Then we have pandas for the data frame creation. We have matplotlib for the plotting purpose for the creation of graph. Then we have seaborn. This seaborn is for the particularly for the distribution of the data. Then what we have done, we have loaded the MNIST data set, and by using this panda library. So PD is, we have identified as pandas, then pd.read CSV, which reads the data.csv file, which is already in my directory. And we are creating a variable data underscore df for particularly this data. Now data underscore df dot head, by default, it will create it will show you 5 different instances. And the size of the data, if we talk about size of each images, so size of each images that belongs to 28 cross 28 here, 28 cross 28. So in total we have 784 different pixels. So pixel is basically nothing but the unit of an image. So suppose there is an image, and if we talk about this particular thing, so this is the pixel value. So there are 784 pixels. If the size of the image is 28 cross 28, that means total there are 784 pixels in the image. So these are the features basically: pixel 0, pixel 1, pixel 2 till 784 pixels. Now, so from which class it belongs to? The first instance belongs to the first digit, second instance belongs to 0 digit, third instance belongs to digit 1. Similarly, fourth belongs to 4, and fifth belongs to 0. Now we have shown here we have shown only 5 instances, but you can see we can check any number of instances. Like suppose if you want to see 10 number of heads, so you can run this by using this, and now we have different instances for 10 different we have classes for the 10 different instances. These are 1 0 1 4 0 0 7 3 5 and 3. So similarly, there are a lot of instances in the data set. If we talk about the shape of the data frame, so you can check there are 42,000 instances in the data frame. For the training and testing, both we will use in the data.csv. We are taking data from the data.csv, and we are checking 42,000 in number of instances with 784 features and one class. Now for the data preparation for the model building, what we will do, we will identify labels as a Y, and we will identify features with the X. So we have two different classes. One is X, two different things. We have one is X, another is Y. Y belongs to only label, and X belongs to feature set. Then if you want to check which type of X, which type of Y is, so you can check by using type function, and you have to provide parameter X for which particular type that belongs to X. So here we have given, and it belongs to data frame pandas.core.frame.data frame. Then for the plotting purpose, for the checking the handwritten digit, we have plot a figure. You can see plot.figure, and here we have given 7 cross 7, and then digit is 1266. So you can check any number of digits. Suppose instance value, if you are giving 70, and so you want to check the what is the image of that particular 70th instance, so you can check that is 3. Similarly, if you want to check, suppose 120th instance, so you can check here, this is 7. Similarly, if you want to check 12th instance, you can check, so this belongs to particularly one digit. If you want to check the distribution among the data, so you have to use Seaborn library file, and for in that particular Seaborn library, we have some count plot function, where we will identify X as a label, and data for the data we will use our data frame, in which our 42,000 number of instances and 784 features are there with the label. So if we run this, so you can check the distribution of data is quite similar. So there are quite similar number of images, or we can say instances for 0th class, 1 class, 2th class, 3rd class, 4th class, 5th class, similarly till 9th class. So there are around 4,000 images for each of the classes. So by using this distribution, what we can derive that we can conclude that our data is balanced. So if we talk about the number of classes for each instances, we have around equal number of images or equal number of instances for all classes. So the data set is balanced. So we are concluding that data set is balanced data set. Now, for the splitting of the this particular data into what we will do for the testing purpose, for the evaluation of the model, of the trained model, we will have to split our data into two forms. One is training data, another is test data. Training, for the training purpose, we will use training data, and for the validation purpose, we will use test data. So for the splitting of our data into two different sets, one is training and another is testing, we will use sklearn library, and there we will import train underscore test underscore split, particular this function for the splitting of data into two form. One is training and another is testing. So for that we have used train test split, and test size we have chosen 0.30. That means 30% of the whole data, of the 30% of whole data we will use for test purpose, 70% we will use for training purpose. So X train and X test, that belongs to only feature, a Y train and Y test that belongs to labels. Labels means output of the instance, that is which particular class, particular class that instances belongs to, either 0, 1 or 9. Now if we want to check the shape of the X train, Y train, and then y test, x test, we can check that also by using shape function. If we will provide xtrain dot shape, so you can see here 29,400 images instances that belongs to xtrain, 29,400 that belongs to ytrain, that is output of the data. Then xtest that belongs to 12 xtest number of instances are there, 12,600 that belongs to xtest. Similarly, 784 are the feature set for the xtest. And then we have 12,600 for the y test, that is label of the data. If we talk about the model, that is KNN, K nearest neighbor. So here what we will do, first we will check for the K value, that is 3. So suppose K value is 3, that means we have to identify 3 nearest neighbor. So for that, we have used sklearn.neighbors, the classifier, and from there we have imported k neighbors classifier, that is knn classifier. So we have taken a variable name, that is classifier, and we have chosen k neighbors classifier. And for the neighbor, total number of neighbors, we are using 3. So if we going to fit that model, we have to use, if you want to train that model, train our model, so we have to use fit function, classifier dot fit, and we have to provide xtrain, that is feature of the instances, features of the instances, and ytrain, that is labels of the instances or output of the instances. Then if we want to train our model, we have to run this. Then for k nearest neighbor classification, we have taken n is equals to 3 or k is equals to 3. Then if you want to predict on the test value, you have to provide that features first, and you can use y, you can put those instances, put those output values in y predict. So if you are going to run this particular, it will take a lot of some time. After that, it is going to predict x text value. And you can see here, so for all the data, you have calculated 0 to 1. That means for all features we have calculated, we have identified from which class it is belonging to. For the matrix, for the performance evaluation, we are using some evaluation metric. So these metrics are precision, recall, F1 score, and accuracy value. So what is accuracy? So in case of, okay, let me show you something first. So suppose there are, this is y actual and this is y predicted. So suppose y actual was 0 and y predicted was also 0. So this belongs to true positive class. But before that, we should have knowledge of confusion matrix. What is confusion matrix? In confusion matrix, we will have 4 different things. One is true positive. Then, so for that purpose, here what we are doing, this is predicted class, or you can say this is actual class and this is predicted class. So if actual class and predicted class both are the same, this belongs to true positive. If actual class is, and here suppose this is positive class, this is positive class, and this is negative class, and similarly this is negative class. So if actual class belongs to negative class but predicted value is positive, so this means this is false positive. Similarly, if actual class belongs to positive class and the predicted is belongs to negative class, that means this is false negative. Similarly, if actual is negative and predicted is also negative, that means it's true negative. So based on this confusion matrix, we are calculating some performance metrics. These are accuracy, these are precision, then recall, and F1 score. So that means accuracy, we have to identify true positive class plus true negative class divided by all true positive values plus false positive values, then false negative values and true negative values. So by using this, we can identify accuracy. So, so we are providing all these values into a confusion matrix. So based on that, we can identify accuracy score. So we have to provide Y test also and Y predicted value also. So by using that, we can identify accuracy. So here, if we are calculating this, so our accuracy score is 0.96. That means 96% accuracy we are achieving by using K value 3. So if we are going to report some classification report, in that we are identifying precision value, recall value, F1 score value, and number of true positive classification. So in this, we have identified zeroth, particularly for zeroth class, we are identifying 97% precision value and 0.99% recall value. And for one, we are identifying 96% precision value, and for the recall, we are identifying 100% recall value. And similarly, for all those classes that those are belongs to this particular digit, which particular digit. And for the confusion matrix, which I have shown earlier in the OneNote book, so this is if you are seeing this diagonal, so this is belongs to true positive and true negative classes. So if we see for the zeroth class, there are 1224 identified. Similarly, all these are the confusion matrix. So here are if we conclude this particular KNN classifier, so for the prediction or for the validation, we are achieving 96.65% accuracy for the K value is equals to 3. Similarly, if we are going to identify for the 5, K value is equals to 5. So we have the same thing we have chosen here. We are using NumPy array, Pandas library, Matplotlib, Seaborn. And Pandas is for data frame, Matplotlib is for the graph purpose, for the distribution purpose, Seaborn is for the data distribution, and NumPy is for the numerical values. But here NumPy, I don't think so. NumPy is using anywhere. But sklearn is using for the, we are using for the machine learning models. Now we are reading our CSV file or you can say our data into data frame. So pd.readCSV, that read CSV function read the CSV file, and our data our file name is data.csv, and we are reading it into data frame data underscore d. If we are going to identify which particular instance belongs to which label, so we can check the instances, top 5 instances. So by default .head will provide you 5 instances. If you're going to change it to 10 or 20, this will show you 20 different instances. Okay, so basically we have not run this particular. Okay, so you can see 20 instances are there. You can see 0th instance belongs to 1 digit. Similarly, 5th instance belongs to 0 digit. 17th instance belongs to 0 digit. 90th instance belongs to 5 digit. You can also identify in the by using showing the figure of that particular 90th instance, or you can say 20th instance. We will check here later. But for first, if you want to check the number of instances and number of features for each of the data, you can check by using shape function. So data underscore df dot shape will give you the number of instances and number of features. So 42,000 images are instances are there, and 784 belong to features, number of features, and one is particularly for the label. Now, for the preparation, data preparation and modeling building, we have to divide our feature and labels among X and Y. So for the data underscore df and for the this label column, that is belongs to Y, and rest of the others will belong to X. So we have dropped the first label axis, and we have chosen all other pixel 0 from pixel 0 to 783. We have given it to the X value. Now if we want to check what type of the X is, this is okay. Here we have not identified the Y and X. Now if you want to choose, check the type of the X. This is pandas.co.frame.data frame, that is pandas data frame. And if you want to check the which particulars, so we have to check 20th digit, that is belongs to 5. So it should be given 5. Okay, there is something. Okay, it may be possible that there this is showing a random number. So some digit 20 we have chosen, that is belongs to 8. So you can check 155. So this belongs to 3. If you want to see the distribution of data, you can use seaborn and count plot function. So you can check here, data is balanced. This basically the distribution of data. We are identifying whether the data is balanced or not. So data balance, if data balance is not there, so the model will give you biased results. So the data should be balanced. An imbalanced data set will give you a biased result. So it will be biased towards that particular class whose instances are bigger than the other instances. So we cannot take that particular we cannot go into that particular problem. So that's why we are taking a balanced class data set. So here, from this distribution of data, we can conclude that our data set is balanced. Now, if we are going to split our data, so splitting of data is into two forms. One is training and another is testing. So by using the sklearn module, sklearn library file, there is a function train test split. By using that, we are dividing our data into two sets. One is training set and another is test set. So X and Y is our training data, and X and Y are the particular data, and we are going to divide them into train and test. So for the train, we are using 70% data, and for the test purpose, we are using 30% data. So that's why the test size is taken as 0.30. Now, if you want to check the shape of the training and testing data, so you can identify by using train.shape and test.shape. So for the training purpose, we have chosen 29,400 number of instances, and for the testing purpose, we have identified 12,600 instances. Now we are choosing k value as a 5. 5 means we have to identify 5 nearest neighbors. So if 5 nearest neighbors that belongs to one class, so the new instance will be belong to one class. So we have to identify 5 nearest neighbor by voting. By voting, we can identify the new instance of from which particular class it belongs to. Here we have used sklearn library file for k nearest neighbor, and we have chosen n is equals to 5, or we can say k is equals to 5, and we are fitting our data or training data to that particular classifier with the k is equals to 5. So if we'll fit this data, that means we are going to train our model. Now, if we want to predict the values on test values, so test data, so we have provided only the feature of that particular test data, and we are identifying the label of that particular features. So if we will provide y predict classifier dot predict, so this will give you the prediction result. Now prediction is completed. So the prediction values are from 0 to 7. This is for the all 12,600 instances. Now, if you want to check the accuracy, as I have already told you about the confusion matrix, based on those the confusion matrix, you have to identify some performance matrices. These are precision, recall, F1 score. You have to identify confusion matrix. You have to identify accuracy score. So here we have already imported accuracy score, classification report, and confusion matrix from the SQL matrix. And we are printing the accuracy score by providing the y actual and y predicted. So y test is actual class and y predict is predicted class from the train model. So if we talk about the accuracy value, this is 0.9635. That means 96.35 accuracy of the training model. So if you are going to draw precision, recall, and FS score of the all test classes, you can see here by using this precision value for the zeroth class is 97. Similarly for the fifth digit, that is 95 precision value with the F1 score of 95. So this is the confusion matrix where you can identify true positive and true false positives, true negative and false negative. And if we conclude the accuracy value of 5 nearest neighbor classification result, that is 96.35%. Similarly, if we talk about this 9 nearest neighbor, that means you have to identify 9 nearest neighbors for the new instance, that is 9 nearest neighbor. Same, the data set is same here again, and we are importing the numpy for numpy is not necessary, but pandas is necessary here. Matplotlib is necessary. Seaborn is for the distribution of the data set. Again, we are importing all those library. So we have already imported. Okay, before that, if you don't have pandas in your laptop or anywhere where you are going to test or train that particular model, so you have to first download these particular library files. If numpy is not there, you have to install that numpy library. If you don't have pandas, matplotlib, and seaborn, you have to install those particular library files in your laptop. So for that purpose, you can use Anaconda. Anaconda tool is there that is used for, that can be used for the particularly for Python purpose. And you can install all these library by using Conda environment, or you can create an environment for your own purpose. You can create your own environment for only machine learning task or for any deep learning task, and you can install all these libraries in those particular in this particular environment. Now for the loading, we are using read CSV function of pandas library, and we are reading this data.csv, which is already there in my directory, and we are reading this particular data into data_df variable. If we talk about data_df variable with the head function, then by default it will provide you 5 instances, 5 number of instances, and with their features. So the first features, this is not feature but the label, or you can say output of the features. So this is label and the rest of other columns that belongs to features of the instances. And these features are in the form of pixel values. So from pixel 0 to pixel 783, that means there are total 784 features are there in the in our data frame. So here again we have data frame dot shape function that belongs to which how many number of instances are there in the particularly in our data frame, and how many number of features are there. In the data preparation for the model building, we are going to drop the first label value, and we will provide this the features into X that belongs to feature only, and we will provide labels or output into Y. So you can check type of the X, that is feature of the instances. And now here again we are identifying the digits. So at 899 instances belongs to 4, and here similarly we have checked the distribution of the data. So all 42,000 images are, we can say, a kind of balanced set, because it belongs to nearby 4,000 images for one class. So we can conclude that the data set is balanced here. And if you want to split your data into two forms, that is training and test. So training is for the training of the model and test is for the validation only. So here we have divided our data into two forms, again 70/30. You can also reduce it with the 20, that is based on your based on your set. So here suppose we have identified that 80% should be for the training purpose, and 20% should be for the testing purpose. So you can also divide that particular set into that form. Okay, data frame is not defined here, so we have to import all these. Then we have to read the data. The data frame is 5. Now shape is 42,000 images. Instances are there with this 785 total number of columns. And we are providing labels to the Y and features to the X here. Now it is belongs to 4. If you're going to identify the distribution of the data, this is around balanced. Now, suppose we are providing 80% to the training set and 20% to the test set. So you can check this particular training size is different from the previous. Now we have 33,600 instances for the training purpose and 8,400 for the testing purpose. Now if we want to change the K value as a 9, so we have already changed here K value as a 9. That means you have to identify 9 nearest neighbor, and here we have already trained. And if you're going to predict this, so we can check that it will take a little bit of time for the prediction of test values, X test. So 8,400 we have test instances, and we have already identified the Y predicted value. Now we have to provide actual class and predicted class. So by using that, we can get the score, that is 96.08. You can also change your training and test size here from here. This particular test size you can use 40% and training for 60%, and then you can check what accuracy you are getting. Now for the classification report, that means precision, recall, and affine score value and confusion matrix, you have to import these particularly function, these particular things: accuracy score, classification reports, and confusion matrix. Then you can check this is precision, recall, and affine score, and you confuse. If you want to check the confusion matrix, this is particularly for the 8,400 instances. Now you can conclude that your accuracy is 96.08%. Similarly, for if you're going to check n is equals k is equals to 27. That means 27 nearest neighbors. So you have to all again import these file and manage load the manage data set. You have to read that particular data.csv, and we have read all these data into data.df data underscore df. We have identified the label and the pixel values. Then you can check the shape of the data. You have to change, you have to drop the label into y and all the features into x. Now you can check the type of the x, and if you want to check these data, so 1266 belongs to 6, and you can check the distribution of the data. This is balanced. So here, suppose we are going to identify test size is 40% and training is 60%. And you are going to split your train test split. So 60% data is for the training purpose. Now you can check 16,800 data are for the testing and 25,200 images are instances are for the training only. So k is equal to 27. We have identified 27 nearest neighbor classifier. And if we are going to predict this, so for the 16,800 images, it will take a little more time than the 8,400 or 12,000 images. Now, for the accuracy score, you can check this is 94%. So from that, we can conclude that, or if we are going to increase value k value, so our accuracy will be lower. And similarly, if we are going to reduce our training size, so that means our test value or our accuracy value is going to reduce. So similarly, here we can create confusion matrix and we can create a classification report. So here precision, recall, and FI score is there. And for the confusion matrix here, we can check for the 16,800 images. So for the 27 nearest neighbor, we have identified 94.35% accuracy value. Okay, so you have to, an assignment will be given to all of you in which you have to predict for the key values of 3, 5, 7, 9, and 11. Or you can identify any of the 5 different key values, and you have to give your classification report with the accuracy value and confusion matrix. So you have to create your own IPYNB file. So, but before that, all these files for the k is equals to 3, k is equals to 9, and k is equals to 7, this will be provided to you on LMS portal, and you can data will be also be provided. Training means training set and testing set also will be also provided, and you have to identify for 5 different k values, these accuracy values, classification report, and confusion matrix. So you have to train your model based on these test set and training set. If you have any confusion till here, you can ask me. If you have any doubt here. No, it's not group project. You have to provide individually. You have to give your IPNB file, notebook file with PDF file. You have an attendance will be marked based on that particularly PDF file. Certificate and attendance both will be given based on submission of assignment. Any other confusion? Any other question? So deadline will be provided to you. I think it's the 15th February or something else. and deadline will be provided to you on LMS itself. Any other doubt? Yes, resources will be provided. These IPYNB file will also be provided. The data set, that means training and testing, both data set will be provided to you on LMS also. Yes, recording is also available on YouTube. This was live demo, so on YouTube it is already available. No, this is not a group project. You have to give individual assignment. You have to identify 5 different key values. That means you can choose 3, 5, 7, 9, 11 or something else. Yes, you have to use uploaded data set that will be given on LMS portal. Deadline will be provided to you on LMS. Just check your LMS portal. And it will be the resources and test set will be uploaded within hour or today itself. Any other doubt? Any other confusion? Okay, I'm stopping this particular meeting here, and all the demo and all the files will be provided to you on LMS. Deadline will be also given. You have to provide your assignment on LMS itself. You have to submit your assignment on portal. Based on that assignment, you will be provided certificate and you will be provided attendance. Okay. Thank you all of you for joining this session.